What's up, Bob Sway, my man? Yeah, okay, so I was gonna give an example of how to get the multiplicative inverse of 37 when the mod is 121. Sometimes he writes that weird, and like he writes it, never mind. He'll probably write it like this. So, to do this, all we have to do, first we have to make sure that the GCD between these two would be 1. So to do that anyway, that'd be the process of getting x anyway. So anyway, the process of solving this is that you would just do GCD 1 to 1, 37. So 121 would equal 3 times 37, which would be 197, 111 maybe? Let me check this real quick. I don't like doing mental math. I'm always wrong with things, you know. Times 37. Yes, it is 111. Cool. 111, and then 21 minus 111, that's 10. You know, just to make sure that's 10. You know, always have to check your work. I think it's just, if you have a calculator, you might as well use it, I guess. Plus 10. See, always make sure I'm right. Why not, you know? So you take those, GCD, 37, and then 10, and then that is going to be, that 37 is going to equal 3 tenths plus a 7. So now we do that again. GCD 10, 7. Now 10 is going to equal 17 plus 3. Oof, why is this thing kind of long, isn't it? 7, 3. 7 equals 2 times 3 plus 1. Finally, we get to that 1. Now we solve for the 1, right? So 1 is going to be equal to 7 minus 2 times 3. So now why do we do this 1 equals 7 minus 2 minus times 3, whatever? So we do that because all of these have been so all of these, not all of these, but like, so this term, like we don't really care what's appended to this term, but this term and that term, all the other terms other than this one have appeared within this sequence before. And all of these are made up of different factors that can also be transformed into higher up factors, also in this line, that all eventually lead up to 37 and 121, right? I don't know if that makes sense to you, but maybe it will. So 7, we knew 7, since it equals 7, that must have been the GCD before. And 2 times 3, and since 3 was the first number of this part, we knew that it had to be here. Now if we replace that with whatever's here, we know these two numbers were in the GCD before it, and that they would have replacements also up here until we finally got to the top. I know it's kind of weird. That's how I kind of think of it and everything. So now let's replace 7 with something a little bit higher up. So, one second, get with my laptop really quick. Also, I haven't done this problem, so I don't know if I'll do it right. I think I should, maybe. Okay, so, you know what, let's replace 7. 7, what's the highest thing we could replace it with? We could actually replace it with this, in which case 7 would equal 37 times 3 times 10, right? So now we replace it here. 1 equals 37 times 3 times, no, 37, what was it? Did I do this one? 37 minus, that's why. You probably noticed that when you were watching this, right? Maybe. Okay. Weird laughs, I know. Minus 3 times 10. And then we do minus 2 times 3. So we replace 7. And then now we have 37 minus 3 times 10. We could actually use 10 to replace it with 30 within terms of 37 and 121, which is what we want. We want the base terms, and any other factors on part of it, like coefficients, we can kind of deal with, So hopefully this isn't getting sloppy. Let's put this around here and that around here. So let's exchange both these 3's to higher up numbers, to 121 and 37. So we can actually do this by doing, actually no, we're not going to do that. We're going to exchange 10 and we're going to exchange this 3 because we don't want to have like any fractions, that are the identities of these things. So 10, all right, let's just replace 10. Focus on placing 10, I guess. So 10 is equal to 121 minus 3 times 37. See, now we're in terms of 121, 37, which is what we want. So 37 minus 3 times 121 minus 3 times 37. 121 minus 3 times 27. Perfect. Minus 2 times 3. It's getting kind of sloppy, I know. Video's kind of long. I think I have enough memory for it. Yeah, it says I do. I think. Anyway, we're going to keep going with this because we're doing good. I still have to study a lot for recursive stuff. And I don't know what's going to be on this test. Study partitioning. He told me to study Bell numbers. So if you watch this video, then you know that I know that he told me to study Bell numbers. That's not really something really specific that would help me out, but who knows. So anyway, let's replace this 3 since we want this into some kind of form with 37 and 121 so it can adapt better with these. So 3. Luckily, 3 was used in this GCD. That means it was used in a previous GCD as its own factor thing. So let's actually do this. Yeah, I just focused it so it looks a little bit better now. So now the camera I'm talking about. Sorry, my mind's kind of scatterbrained, maybe not. Where it is. 10 minus 7. So you see what I did here? I just solved for 3. I subtracted the 7, 10 minus 7. And that's what I wanted in, because now I could replace the 10. And I could replace the 7. It's getting kind of. Maybe I'm doing some extra steps. Either way, it'll all lead me to the right path in the end. How about like I just omit this part for a second so I could just focus on getting this, because this part's in good terms. We have 37 here. We could we could distribute that and we'll still have in terms of 27 and 121. But this is the problem right now. So let's just omit this for a second and let's just call this, let's do what mathematicians do to make things confusing, or kind of not confusing because they don't know another way. Let's call this C for confusing. So confusing variable, maybe. So I'm just omitting this. Like C is this. I just don't want to write it out because it's cleaner. C minus 2 times, and we kind of substituted 3 already, so I could just put 10 minus 7. Oh, that's. Now I want to substitute the 10, and I want to substitute the 7. In which case, I could make the 7. Luckily, we already substituted the 7, and we already substituted the 10. Makes things very easy for us. So now, minus, we'll see. Let's just write it all out. 2 minus 2. I feel like you're just watching me solve a problem. I might even get to the right answer at the end. Well, I think it's important to see the insights of all fellow students because we're all valuable in our own way. So I'm replacing the 10 right here. All right, minus 3 times 37. Good, good. We're getting closer to our goals. Minus, except for this 7. 7, we have to replace it. 37 times 37 minus 3. I'm probably doing a lot of extra work that I shouldn't be doing. Times 10. So now that 2 is still multiplying all of this, so I put that there. And now I still have to replace this 10 to put it in terms of all this. I just can't help but think that I'm doing something longer than I should. But like I said, all you have to do is get the right answer. Technically, if I wasn't talking, I think we would get to this in half the time. Anyway, let's replace the 10 and we could be done with this. So let's just write it all out now. So 1 equals 37 minus 3 times 121 minus 3 times 27 minus 2 times 121 minus 3 times 37. He gave me this problem personally and he said solve it and I'll help you understand things. So maybe it's supposed to be messy. Who knows? 37 minus 3 times, now we're going to replace the 10 right here. 10 right there. 21 minus 3 times 37 and replace it with that 10. And then we close it all. So now let's try and evaluate some of these things. So 3, 121, so we could actually just put 37 minus, well 1 is still equal to it. 37 minus 3 times 31. To write that, I don't actually want to work it out. So I'm just actually going to put it like this. 927 minus, so 2 times 121 to 121 minus 637 minus 37 minus 3 121 minus 9 37. Watch, I made a mistake here and I don't even notice, but you will. You will. So let's look at the big picture here. 37. We could just kind of put this coefficient here. So we could, like, we know that little thing with numbers where you could kind of treat the thing you're multiplying by as like a variable kind of thing. So like imagine this as like 1x, 3y, 9z, 2y, like, so we could put them together. So this is like 1 and 37. So let's take all the 37s. Yes, I changed this into a 27, 37. See, I'm making mistakes everywhere. 37. I might be making more. It would suck if I am. Let's just focus on these. 37 minus 9. So 1 minus 9. That's negative 8 times 37. That's just these combined two. Negative 3 minus 2, because like we're putting these together. So minus 5, 121. He told me I'd get negative things. That was the whole point of him giving me this thing. So we took this one, and we took this one, and we took this one, and we took this one. And then now let's group these a little bit together a little bit more. So minus 7, 37, minus 737, because minus 737 because I'm sorry that I didn't explain. This is negative 637. I'm subtracting it by this 37. So you can just kind of imagine it like that, 1 times 37. And if we're trying to imagine like this as kind of like a variable, and these are constants that we could change because they're like coefficient of the multipliers, then that would be negative 737. So I just took these two out. And then minus 3, I'll just write these out verbatim. Minus 937. Now we dramatically reduce the problem, and that's just bring the rest of the 37s together. So minus 8, minus 7, that's negative 15. Minus 9, that's negative 24, I think. Negative 24 times 37, or, okay. Now negative 5. I probably did stuff wrong. Yeah. I think I distributed wrong. -3, 121. That should have ended up positive. You know what? I don't know if I want to waste your time more with this video, but you kind of see what I'm doing here, right? If I didn't distribute wrong, then I'd eventually end up with numbers like whatever 5 times 37 with whatever 8 times 121, whatever. What's that, 121? Yeah. And then all I would really need to do is get the 2 for these, like the other number here, to see what multiplies together to what would be the GCD of 121 and what would multiply together, so I could plug it in here, because that's what would equal the 1 anyway. Because no matter, like, 8 times 121 is still going to be a multiple of 121, so that mod is going to be the same either way, right? Because it makes sense in my head. I hope it makes sense to you. Because if we're like this times that, and then if that's the GCD between these two, which is what we're modding by, and this number, and it all equals 1, then that, I don't know, that's just how it works, right? So this other factor is just going to be x. I'm sorry, I can't explain it. It makes sense in my head. It's going to take too long. It's waste too much video. And then that's going to be x. Then you plug it in, and then that gives us like the inverse of whatever we're looking for. So the inverse of 37, the multiplicative inverse of 37 would be essentially the GCD between 37 and 121. After you get the 1 and you replace it, and you find the factors of 37 times whatever number, whatever with this operation, that would equal 1. So whatever the coefficient ended up being for here, 37, once you plugged in everything for 1, is what would end up right here to give you the multiplicative inverse of this. Alright. Cool. I didn't get it right, but hopefully it taught you something.